Welcome to the viewers. Now we discuss bipartite graph. To getting the idea this bipartite graph, let us consider let G dash be a simple graph and let V dash be the vertex set. Then V dash can be partitioned into two subsets. If we consider it as a V1 dash and V2 dash in such a way that each edge of G dash has one end and that means actually one end point and other end point that means each edge of one end and other end point edge of actually other end point in V2 dash. So the pair here is these two pair one end point that is V1 dash and G has one end point V1 dash actually it is a V1 dash and the other end point in V2 dash actually. So this pair that is V1 dash and V2 dash is called bipartition of G dash and V1 dash and V2 dash are called the bipartition subset. Bipartition subsets. Now if we give some pictorial representations, if we consider let the vertex set V that will be given by V dash that will be given by U1 dash, U2 dash, U3 dash and V1 dash, V2 dash, V3 dash and the bipartition subsets are, if we consider V1 dash, that's a bipartition subset. If we consider V1 dash, that is U1 dash, U2 dash and U3 dash and V2 dash, that is V1 dash, V2 dash and V3 dash, then we consider the figure. At first, we consider the two bipartition subset consisting of U1 dash, U2 dash and U3 dash. u1 dash, u2 dash and u3 dash. Here also v1 dash, v2 dash and v3 dash. Now if we are joining these two, one edge you connect, that's joining incident with v1 dash, u1 dash also if we incident with v2 dash. Then if we consider this type of figure, that's each edge of the bipartition graph, one end is the lying the set of v1 dash and another end is on v2 dash. That first edge, if we consider this edge, if suppose we take as if edges, that's each edges, that is if we consider here e1 dash be the edges, e2 dash, e3 dash, e4 dash, in this way e5 dash, if we get some of the edges. And if we consider if e dash be the set of edges consisting of e1 dash, e2 dash, e3 dash, e4 dash and e5 dash, and omega dash be the incidence function, then they are incident with, actually that is omega dash, that's incident with v1 dash and u1 dash and u2 dash, that's incident with u1 dash and v1 dash. Edges is u1 dash, u1 dash v2 dash, edges is incident with the edges e2 dash, u2 dash v2 dash, that is e3 dash, u2 dash v3 dash, that is e4 dash, and u3 dash v3 dash, that is e5 dash. So if we consider here the edges u1 dash, one end lies on the set of u1 dash and another end lies on the set of v1 dash, and e2 dash, one end is on the set of u1 dash. So every set, a member of u1 dash one end and connect incident with another edges vertices, that is v2 dash. So all these sets u1, u2, u3 are on v1 dash. So it is lying on the set of one end lying on the set of v1 dash and another end lying on the set of v2 dash. u1 dash cases that satisfy, e2 dash also same cases, one end is on v1 dash, is a member of set u1 dash and another end incident with v2 dash. So in this way we find all the edges that satisfies this criteria of bipartite graph. So we find here the bipartitions, and this type of bipartitions, that's every edges. So we can conclude it that every edge in G dash has one end point in v1 dash and other end point in v2 dash. So we get the ideas of bipartition graph, bipartite graph, not bipartition, bipartite graph, and this bipartite graph we consider here. Now if we consider the complete bipartite graph, another in considerations, complete bipartite graph. If similar cases, if a bipartite graph, let us consider, better to say, G dash has two bipartitions subset, has two bipartition subsets v1 dash and v2 dash, has two bipartisan subsets v1 dash and v2 dash. If there is an edge between each pair of vertices u dash and v dash, if we consider where u dash is the member of v1 dash and v dash is the member of v2 dash, then a complete bipartite graph G dash consisting of m vertices, suppose m dash vertices, and m dash vertices actually in one subset, in one, this is better to say bipartisan subset, that is v1 dash, bipartisan subsets, and n dash vertices in the other bipartisan subset. It is denoted by like k m dash n dash in this way. And if we considering it, what happens there, because that's in these cases, particular cases, that's one bipartisan subset, that is every complete bipartite graphs having the vertices of one bipartisan subset and another number of vertices, that's other bipartisan subset, that is a subset. This bipartisan subset is denoted by k m dash m dash, this bipartisan subsets. Actually it is means this bipartisan subset. Now let us see with the help of an example. If we consider here k, suppose 2 3, what happens there, that is a number of vertices 2 here. If we consider these vertices are the elements of v1 dash, okay, that's a v1 dash. If we consisting of here the set of v1 dash like this, u1 dash and u2 dash, if we consisting of this type of set, because we consider here u dash v dash, u dash is the member of v1 dash and v dash is the member of v2 dash actually. So this u dash, if we consider this and like the subsets of bipartisan subsets actually, so actually pair of vertices means that sum of the pair, if we consider it, and number of vertices, that is u1 dash and u2 dash, and another case is be the considering the number of like this v2 dash. If we consider here v1 dash, v2 dash and v3 dash, what happens there, u1 dash, u2 dash, here v1 dash, v2 dash and v3 dash. Now we draw u1 dash must be incident with v1 dash, one end lies u1 dash, that's incident with u1, and another end is v1. Now u1 that's incident with v2 dash and u1 is incident with v3 dash. So here you observe in every one that's incident, one end is u1 dash and another end is v1 dash, then u1 dash incident with v2 dash, then u1 dash incident with v3 dash. So in the earlier situations of general bipartite graph, we don't consider it. We just consider here that one end is one vertices may not join all of the sets of vertices, but here it is not. In the complete bipartite graph, every end of vertices lies one set and another end is incident with vertices of another type of set. Here U1 that's incident with every member of the vertices of that means every U1 dash that's incident with every member of V1 dash, V2 dash and V3 dash. That is every member of capital V2 dash if we consider here in this set. And it is also the same things for U2 dash. So U2 dash that's join with V2 dash, that's an incident with V1 dash, and U2 dash also incident with V2 dash, and U2 dash also incident with V3 dash. So in this way we find K23. Now if we consider any type of size in this graph like 3 4, what's happened there, and also if we consider the edges U1 dash, if we consider here like E2 dash, if we consider here E3 dash, and if we consider here this joining E4 dash, and here if we joining as E5 dash, and here E6 dash, in this way this pair with connected with if omega dash be the incident function and E dash be considered as U1 dash, E2 dash, E3 dash, E4 dash, E5 dash, E6 dash, in this way, and omega dash be the incident function. That's incident with this. So in this way this pair of vertices joining this. And if we consider here K34, then here V1 dash be the set consisting of U1 dash, U2 dash, U3 dash, and V2 dash that consisting of 4 points of vertices, 4 vertices, V1 dash, V2 dash, V3 dash, V4 dash. Now if we draw the representations U1 dash, U2 dash and U3 dash, and here also V1 dash, V2 dash, V3 dash, V4 dash. So if we join U1 dash incident with all the points of V1 dash, V2 dash, V3 dash and V4 dash, just joining. Similarly that's incident and joining, and another cases that's incident and joining. So in this way we join all these cases. If we consider it as E1 dash, E2 dash, E3 dash, E4 dash, here we consider as E5 dash, E6 dash, E7 dash, just made a mistakes, and we can't join because the figure is too much clumsy, so that's we rewrite the figure once more for the clear understanding. We cross it, reconsidering U1 dash, U2 dash, U3 dash, 3 points here, 4, V1 dash, V2 dash, V3 dash, V4 dash, joining all these points U1 to, that's bipartite with every elements. Similarly joining this every element bipartite. Yes. Next for joining this element, this element, this element and this element. So u1, that's the bipartite. So join incident with v1 dash, v2 dash, v3 dash, v4 dash. u2 also v1 dash, v2 dash, v3 dash, v4 dash. u3, that's also joining v1 dash, v2 dash, v3 dash and v4 dash. So it is a complete bipartite graph. And already if we consider the figure, looks like too much clumsy if we put all the edges, and we can get actually the proper figure. That looks too much clumsy and we don't understand it. If we incident with e1 dash, and if we incident with e2 dash here, if it is e3 dash incident this and this, now this e4 dash, and now this 1 2 3 4, another for second cases, that is e5 dash incident with, if we consider here e6 dash, and if we consider here e7 dash, and similar cases of it is e8 dash, u1 u3 dash and v1 dash. This edge if we name, taking the name of e7 dash, e8 dash, if this case is 1 2, e9 dash 1 3, that is e10 dash, and e4, that is e11 dash, e9 e1 dash, e2 dash, last elements, that is e8 dash, e9 dash, e10 dash and e11 dash. e1 dash, e2 dash, e3 dash, e4 dash, e5 dash, for the second cases e5 dash, e6 dash, e7 dash, e5 dash, e6 dash, e5 dash. Oh, this is just a mistake here, we don't name it. If we take the name another e6 dash, okay, we just don't taking the name of u1 u2 dash, that's incident with v2 dash. Just for sake of the simplicity, this is the arbitrary name, so if we taking it as e12 dash, no, not a problem at all. So we are taking all these edges, that is if we consider here e dash consisting of the edges e1 dash, e2 dash, e3 dash, e4 dash, e5 dash, and like e6 dash, e7 dash, and also e8 dash, e9 dash, e10 dash, e11 dash, e12 dash. But here if we write the notation, if omega dash be the incident function, omega dash of u1 dash, we write the name for the getting the clear idea. That's a incident with the edges, pair of edges u1 dash, v1 dash, now omega dash of E2 dash, that is the cases of U1 dash and V2 dash, omega dash of E3 dash, this is cases of U1 dash and V3 dash, omega dash of E4 dash, that is the cases of U1 dash and V4 dash, omega dash of E5 dash for the second case is E5, that is of U2 dash and V1 dash, omega dash of, it is the cases of U2 dash and V2 dash, that is we name E12 dash, that is U2 dash and V2 dash. Here is the arbitrary name, omega dash of U2 dash V2 dash. Now U2 dash V3 dash, that is E6 dash, that is U2 dash V3 dash, and omega dash of E7 dash, that will be U2 dash and V4 dash, omega dash of, that's a 4 4 8 8 12 E7. Next case is E8 dash, that's connected with U3 dash V1 dash, omega dash, that's connected with E9 dash, that is U3 dash V2 dash, omega dash connected with E10 dash, that is U3 dash V3 dash, and omega dash connected with E11 dash, that is U3 dash and V4 dash. So in this way, for getting clear idea, we rewrite how the incidence functions occur between the pair of edges. So we have got the idea, because the figure is too much clumsy, that's why we rewrite this type of relation to draw this type of shape. This is a conception, and we should apply the actual process or method and how to draw this type of representations. We draw with the help of this incident function. So here one pair that's incident with the set of V1 dash, like this V1 dash, if we consider here V1 dash be the set of this, and another pair is V2 dash, that's every pair incident with every another pair. So that's why it's a complete bipartite graph. So in this way we can draw many bipartite graph like K22, K whatever may be, but here if we consider here U1 dash, U2 dash, V1 dash and V2 dash, it is also taking the complete bipartite graph in this way. U1 dash, that's also incident with V1 dash and V2 dash, U2 dash also the same cases. So in this way easily draw K22 figure, no problem for that. So now we end our discussion, and we have got some idea how to draw the how to representing the complete bipartite graph and some of the ideas. If you like this video, like it, share it, and subscribe the channel. Thanks for watching.